Hello students, welcome to Vyas Edification Kota. It is time to continue further with NCERT class 11th, and yes, we were seeing the chapter Permutations and Combinations, the lovely chapter, and it is time to move on to exercise number 7.3 over here. This exercise, mind you, is based on permutations, that is permutation of different objects, alike objects, and all of those things will come over here in this exercise number 7.3. And yes, let's not waste any further time to move on to the first question of this exercise, which says, how many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated? Now this question is similar to the fundamental theorem of principal questions which we solved in exercise number 1, right? We can use similar ideas or we can use ideas of permutations. Now personally, I would always prefer in such questions, you can always use fundamental theorem wherever required, right? Let's try to use fundamental theorem and see where does that take us. How many 3-digit numbers can be formed by using the digits 1 to 9, no digit is repeated. So you have a 3-digit number which is supposed to be formed and no repetition, okay, digits 1 to 9, there are 9 possible cases, right? So this can be filled in 9 ways, this can be filled in 8 ways, this can be filled in 7 ways, that's what you'll have, right? So the total number of ways would be actually this times this, which is once again 8 plus 1, 8 minus 1 is actually 8 square minus 1, okay, and you have a 8, so that would become 8 cube minus 8, 5 and 2 minus 8 is 504 is the answer for this question. This is using fundamental theorem. If you're asked, let us say how many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated is, so you have total 9 digits and you have to choose, basically you have to actually, don't use C yet since you haven't studied C in this exercise. Once you study C, that is combination, you should always prefer using C. But for now, let's see what we can do with that P. So how many 3-digit numbers? We have to permute 3 out of these 9. Permute 3 out of these 9. This is 9p3. And 9p3 is equal to 9 factorial over 9 minus 3 factorial, which is 9 factorial over 6 factorial. This is 9, 8, 7, 6 factorial over 6 factorial. This goes. And we get that exact same thing, which is equal to 504. That's the alternate approach, which you may be interested in knowing since this is exercise based on permutation. So how do we use permutations? This is how we use permutations over here. Out of 9 available, you have to fill in 3 boxes, right? Out of 9 available digits, you have to only fill 3 boxes over here, right? With those 9 available digits. So you permute 3 out of those 9 over here, right? That's what you get. That's the complete solution of this first question. Let's move on to the next one. How many 4-digit numbers are there with no digit repeated? Okay, so we are interested in no digit repeated and 4-digit numbers. We are interested in 4-digit numbers. Okay. Once again, the way I mentioned in the first question, I clearly mentioned that it is better to solve using directly fundamental theorem if possible, right? So let's see how many 4-digit numbers are there with no digit repeated. There are no repetitions. The digits are 0, 1, 2, 3 up till 9. Those are the possible digits, right? So this particular place, since you want to create 4-digit number, so 0 will not be allowed over here. 0 will not be allowed over here. How many possible choices are there in that case? You will have total out of 10 digits, you will have only 9 possible digits over here. Now 1 digit has already been used. Let's say you use 1. So remaining how many digits are allowed over here? How many digits are there which are allowed over here? Out of 10, you have used 1. Oh, now the 0 comes back. Yes, because 0 can be allowed over here. Right. So this again has 9 possible choices. Next one. Out of 10, you have used 2. So this will only have 8 possible choices. Out of 10, you have used 3. This will have only 7 possible choices. So this is what you get. These are the total number of 4-digit numbers with no digit repeated, right? Total number of 4-digit numbers with no digit repeated. This is what we have, right? 9 times 9 times 8 times 7, and this is pretty easy to calculate. This is 8 plus 1, 8 minus 1, and this is 8. So this becomes 8 square minus 1 into 8 will be 8 cube minus 8. This is 504. 9 times 504 is what I'm interested in. 9 times 4 is 36, 9 times 5 is 45. So this is 4536. 4-digit numbers are there. Mind you, how many 4-digit numbers are there in total? Another question based on this. Let's say there are total actually 4-digit numbers. These are the total 4-digit numbers that are there with, these are the total 4, no. The total number of 4-digit numbers will not be this. Total number of 4-digit numbers can be found using ideas of permutation combination once again, or you can use directly common sense from the case that 4-digit numbers end with this and they start with this, right? So what you can subtract is, subtract the 3-digit numbers from here actually, that is subtract 999 from here. This is actually 9,000 4-digit numbers in total, which can be obtained with the help of permutation combination also, that this place can be filled in 9 ways, this place can be filled in 10, 10 and 10, since there are 10 possible digits and repetition is allowed or not allowed doesn't make a difference. If repetition is allowed, that's the total number of ways. This is also 9,000. But this is a total number of 4-digit numbers. That's pretty simple. You can find it directly or using this concept. The question that I want to ask is, on the basis of this data is that how many possible 4-digit numbers are there? Listen to this carefully. How many 4-digit numbers are there with at least one of the digits repeated? With at least one of the digits repeated. Okay. In which at least one of the digits repeat. So how will we go about solving this one? Now that can be solved with a simple idea that there are total 9,000 numbers, 4-digit numbers, and there are certain 4-digit numbers which do not have any repetition of digits. Right. Other than these, the numbers which you obtain will have some repetition. Yes. So subtract 4, 5, 3, 6 from here. And what do you get? You get this is 4, this is 6 and 4 and 4. 4, 4, 6, 4 is your answer. These many 4-digit numbers will have at least one repetition. At least one repetition. Can have more, yes, but at least one repetition is what you will get in this case, right? That's another question based on this. This is what was required over here, and this is what we have seen extra with this question. Let's move on to the next one after this. Third question, how many 3-digit even numbers, okay, we are talking about even numbers now, can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated, right? We are supposed to be concerned with even digits, right? 3-digit even numbers. So this digit has to be even, and what are the possible choices? We have 1, 2, 3, 4, 6, 7 and no repetition. So even digit would imply this can be either 2 or 4 or 6. There are 3 possible choices for this box over here. And what are the other possible choices? 3-digit even numbers can be made if this is either 2 or 4 or 6. What about this one? Out of these numbers, there are 6 digits, right? Out of these 6 digits, you have used 1, so 5 possible choices will be available over here. Out of 6, you have used 2, so only 4 choices would be available over here. And this is what we are looking forward to. What is this? This is 60. 60 possible 3-digit even numbers can be formed using the digits this, if no digit is repeated. That's my answer for this question over here. Third question. Let's move on to the next one. Fourth, find the number of 4-digit numbers. Now we are talking about 4-digit numbers over here that can be formed using the digits 1, 2, 3, 4, 5. If no digit is repeated, how many of these will be even? Okay, so there are 2 parts of this question. 4-digit numbers formed using the digits 1, 2, 3, 4, 5. Okay, and no repetition. That's what the person is saying. If no digit is repeated, right? Number of 4-digit numbers. So for 4-digit numbers, what we can do is, since no repetition is allowed, we can directly use concepts of permutation, right? 5p4, or another idea would be to actually fill this using 5 options available. Then no repetition, this will have 4 options. Then no repetition, this will have 3 options, and this will have 2 options. This is this, which is actually equal to, if you had a 1 also, will that make any difference? No, this is actually 5 factorial, which is 120, right? That's my answer. Or you could have also used ideas of permutation. This is 5p4. These 5 have to be arranged at these 4 places. So this is 5p4, which is 5 factorial upon 5 minus 4 factorial, which is 120 over 1, which is 120. This is alternative idea. But that's just the first part. There's another part to this question. How many of these will be even? How many of these 120 numbers will be even? So for that, let's draw the boxes once again, And for even, this place has to be even. So what are the possible choices over here? You observe only 2 and 4 are allowed over here. There are 2 possible choices with respect to this. Once you have filled this one, the next one, either this or this, can be filled in how many ways? You use one number, so you're left with only 4 possible numbers, 4 possible digits. This can be filled in 4. Next can be filled in 3 and the next can be filled in 2. Right? Because for this one, you have already used 2 digits, only 3 options are remaining. Okay, so this is what you get, right? These are the total number of possible even digit numbers that can be found without repetition, when repetition is not allowed. What is that? Is 6 times 4 is 24 times 2 is 48 possible even numbers. This is second part, even numbers, right? How many of these are even? These are even, right? 48 numbers out of these 120 are even. And how many will be odd, if that is also asked? So for finding odd, what we'll do is the last place can be filled using 1, 3 and 5, right? That's the idea. Or what you can do is, after finding this, you can simply subtract 120 minus 48 will give me the number of odd numbers, right? That's what you can do. Is that okay? That's pretty simple, right? Let's move on to the next question after this. Fifth, what does question number 5 say? From a committee of 8 persons, there's a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? Okay, we are supposed to choose a chairman and a vice chairman. Actually, from a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? So we actually have, let us say, 2 chairs basically, and we have total 8 persons. They are waiting to sit on that chair. And how many ways can you arrange them on these 2 chairs, right? So this chair can be filled in 8 ways. This chair can be filled in corresponding 7 ways. Mind you, the same person cannot occupy both the chairs, right? So this is total 8 times 7, which is 56 ways. Alternatively, you could use concepts of permutation, that is 8p2. 8 persons, 2 chairs, and this is what you get. 8p2 is same as this 56 over here. And yes, that is my answer for this question over here. Is that all? Yes, that's all that you have. Sixth one. You have an equation in terms of P. Okay. So how do we solve that? Let's see. Find n. N equals question mark. If n minus 1 P3 is to n P4. Okay. This is to n P4. So that can be written in the denominator. This is n P4 is equal to 1 over 9. That's the question that we have, right? Let's apply the formula that we know. So NPR is equal to n factorial over n minus r factorial. So this n minus 1 P3 will become n minus 1 factorial divided by difference of these two, that is n minus 1 minus 3 will be n minus 4 factorial. Okay. In the denominator you have n P4, which is n factorial, and you will have n minus 4 factorial in the denominator's denominator. This is equal to 1 over 9. Since this is equal to 1 upon 9, you can see that these two terms will get cancelled. This has one extra term over here. N factorial is actually n times n minus 1 factorial. This goes with this. Therefore, 1 upon n is equal to 1 upon 9, and this will tell me that n equals 9. That is my answer for this question over here. N equals 9 is the final answer for this question, question number 6, as you can see behind me, right? That's a complete solution for this question. Let's move on to the next one. This, find R if there are 2 options available over here. And once again, the approaches would be pretty similar to the previous question which we just saw. Let's apply the formula for NPR and see where does that take us. So in the first part, what do we have? You have 5PR is equal to 2 times 6PR minus 1. Okay. So let's apply the ideas. This is 5 factorial over 5 minus R factorial. Okay. This is equal to 2, which is okay. And this is 6 factorial over 6 minus R, and minus of minus 1 will become plus 1. That becomes 7 minus R factorial, right? After simplification, right? 6 minus R minus 1 will become 6 minus R plus 1, which is 7 minus R. That's what I've used over here, right? This is something which I've calculated in rough. Okay, so 7 minus R and 5 minus R, which do you think is bigger number? 7 minus r seems bigger, right? This is a bigger number, right? This is a smaller number. So 7 minus r will have 7 minus r, one term. Then it will have 6 minus r, one smaller number. And then it will also have 5 minus r factorial, right? N is equal to n factorial is equal to n times n minus 1 factorial. This 5 minus r factorial in the denominator goes with this. Okay. Similarly, 5 factorial and 6 factorial, this will be 6. So what you get is, let's write, this will go over there. This is 7 minus r times 6 minus r is equal to 12 over here. 6 times 2 is 12. Let's multiply, frame the quadratic and get the value of r after this. So this is r square minus 13r, 42 minus this is plus 30 is equal to 0. This gives me r equals 10 or 3. There are two possibilities of r equals either 10 or 3. Now for this 5pr to be defined, r should be less than 5, right? So 10 will not be acceptable, r equals to 3 is acceptable. Therefore, final answer for the first part is r equals 3. That's the final answer for the first part, as you can see. Okay, what about the next part? Let's solve the next part after this. Over here, this is done, right? We are done with this one. Let's solve the second part over here. We have 5pr is equal to 6pr minus 1. Now in this one, we'll have 5 factorial over 5 minus r factorial is equal to 6 factorial over, again 6 minus r, and minus of minus 1 will become plus 1. So this becomes 7 minus r factorial. In a similar manner, as we saw over there, this is 6 and this will give me 7 minus r times 6 minus r in the denominator, right? In the LHS, both of these products will be r square minus 13r plus 42, which is equal to 6. So this becomes r square minus 13r plus 36 is equal to 0. Solving this, you can solve this, factorize this. Yes, 36 is actually 9 times 4. So r will be equal to 4 or 9 as per this equation. But let's check the condition. Let's check the condition. 5pr implies that r should be less than 5. So this is not acceptable. This is acceptable. Therefore, r is equal to 4 is my answer for this question over here. That's the complete solution, as you can see behind me, and that's all that you have over here in this question. Let's move on to the next one. 8. How many words with or without meaning? Okay, words are supposed to be formed with or without meaning. Okay, can be formed using all the letters of the word equation, using each letter exactly once. Now, this is the first time that we are encountering formation of words along with this chapter, right? So, how many words without meaning can be formed using all letters? So, equation, E, Q, U, A, T, I, O, N has how many letters? There are total 8 letters. Okay, is there any repetition? Let's check that out. E is not repeated, Q is not repeated, U is not repeated, A is not repeated, T is also not repeated, I, O, N are also not repeated, right? So there is no repetition, okay? And you have 8 possible boxes. 1, 2, 3, 4, 5, 6, 7 and 8, let's say. So equation, each alphabet has to be arranged in each box over here. And how many words with or without meaning can be formed using all the letters? Using each letter exactly once. Basically 8 arranged over 8 places would be 8 factorial. This is what you'll have, right? 8p8 or 8 factorial directly. And what is that value equal to? Let's find 8 factorial. So 8 factorial is 8 times 7 times 6 factorial, and 6 factorial is something that I remember, right? 6 factorial is something which I remember. This is 8 times 7 times 6 factorial is 720. You should remember this. This is 8 times 7 times this. 7, or you can multiply 8 times 7, 56 times 72 as well. But let's multiply, this is easy. This is 5040 and this becomes 0854 is 32. Okay, 8 times 5 is 40. So this is 40320. That's what we have over here, right? In this question. This is question number 8. Let's move on to the next one after this. 9th. Okay, there are plenty of parts of this question. How many words with or without meaning can be made from the letters of the word Monday? M-O-N-D-A-Y. Okay, there's no repetition over here. Assuming that no letter is repeated, if 4 letters are used at a time. Okay. All letters are used at a time. All letters are used, but first letter is a vowel. Okay. So let's solve each part one by one. The first part and the second part seem very simple. You have 6 possibilities and only 4 letters are used. This is 6P4. Arrange 4 out of 6. Or alternatively, we could have filled these 4 boxes using alphabets from there. MONDAY. This is 6P4, which is 6 factorial upon 6 minus 4, 2 factorial. This is 6, 5, 4, 3. Same thing will come over here. What is this value equal to? This is 6 factorial upon 2 actually. Had there been a 2 and 1, this would be a 6 factorial. So this is 720 upon 2, which is 360. Oh, I can multiply them as well. Yes, you can multiply them as well. That's not an issue. 4 times 3 is 12 and 12 times 30 is this 360. That's my answer for the first part. Right? For the second part, what do we have? All letters are used at a time. Okay, so in this case, you'll have 6 boxes and 6 places. There's 6 factorial, which is 720 ways. That's the answer. Very simple, yes. All letters are used, but first letter is a vowel. Now that's interesting. All letters are used means you need to fill 6 boxes. But the first letter is a vowel. Whenever you are asked to differentiate between vowels and consonants, first note the vowels separately. We have M is a consonant, O is a vowel, N, D, A, Y. So these are consonants and these are vowels. And the first letter is a vowel implies that this can be filled in only 2 possible ways. The next can be filled in how many possible ways? Out of 6, you have used 1. So this can be filled in 5 possible ways. You can use the other vowel remaining, right? Obviously. Next can be filled in 4 possible ways, then 3, then 2, and this will only have 1 choice. And this is what you get. This is 2 times 5 factorial. What is that? 2 times 120, which is 240. Yes, that's the possible number of ways of filling these 6 boxes given this condition. All letters are used, but first letter is a vowel and no letter is repeated, mind you. So first letter, this can be filled by either O or A only. If you use O, that will not be repeated anywhere, but A can be filled over here. If you use A will not be repeated, O will come somewhere over here in that case. So 2 choices for this and remaining for this, right? That's what you get. Is that all? Yes, that's all that you have in this question. Moving on to the next one, 10th. 10 says, in how many of the distinct permutations of the letters in Mississippi do the 4 I's not come together? Okay, the 4 I's do not come together. That's what the person is saying. How many of the distinct permutations of the letters in this? So permutations of Mississippi, let's write the word properly first. Write what are the like letters. Let's club them together. We have M, we have I. Okay, we have S, S, then you have another I, then you have S, S, then you have I, and then you have P, P, and another I. So there are 4 I, 4 S, 2 P, and 1 M. Let's count. 4 plus 4 is 8, 9, 10, 11. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that we don't miss anything, right? How many of the distinct permutations of the letters in Mississippi do the 4 I's not come together? Okay, so let's think of an alternative approach. If there are total number of permutations, there will be some arrangements in which the 4 I's come together, and there will be some other I's in which the 4 I's do not come together. Maybe 1 or 2 3 will come together. So we can easily find that case when the 4 I's are together, and we can find the total. So the difference will give us the answer of this one. Yes, yes, yes. That's what we are supposed to do. So total minus rejected is the approach that will follow over here. Total number of ways is arranging these 11 alphabets at 11 places. So what you'll have is 11 factorial over repetition of I's. There are 4 similar I's, so we'll have to divide by 4. 4 similar S will have to divide by 4. 2 similar P's will have to divide by 2. Minus rejected, in which these 4 I will be clubbed together. Right? They will act as one unit because they have to be kept together for the rejected cases, right? When the 4 I's come together, that case is rejected. Right. So we'll have 1, 2, 3, 4, 5, 6, 7 and 1 bag. 8 things being arranged at 8 places. This is 8 factorial divided by these 4 and these 2 are alike letters. They will have to divide by these 2, right? The 4 I's that are present in the bag, their internal permutation will not have any impact, right? Their internal permutation will be 4 factorial, but they are all 4 alike, so we'll have to divide by 4 factorial again. So 4 factorial times 4 factorial, which is actually 1. Their internal permutation will be Right? The 4 i's come together and they are alike, therefore 1 for that. And this is the final answer that we are interested in. 11 factorial upon this minus this and this. So let's see, where does that take us? This number is 11. This number is huge, by the way. Right? 11 factorial will be pretty huge. 8 factorial upon 4 factorial, 2 factorial can come out common. Right? Let's bring that number common. We'll have 8 factorial over 4 factorial, 2 factorial coming out common. What will remain is 11, 10, 9. Okay, then you had 8 factorial is gone, 4 factorial, 2 factorial is gone, and this is 4 factorial, 4, 3, 2, 1 at the denominator. That's what we have, right? Minus, you have a 1 over here. Minus, you have a 1 over here, right? This is what you get. And using this, let's try to solve this one. 8 factorial is 8, 7, 5, 6 times 4 factorial. So this is 8, 7, 5, 6 over 4 factorial is 4 factorial and 4 factorial times 2. This goes, what is this? Let's multiply them together. Can we cancel some things? Yes, we can cancel some things. But we can also see that if you cancel a factor of 2, that will unnecessarily give us a 5. 10, multiplication with 10 is very simple, right? So this is 99 times 10 is 990. 990 minus 24 is what we are interested in. On taking the LCM, this is what you are interested in, right? Denominator is 24, if you observe that carefully. So, can we handle that 24 as well? Yes. 8 times 6 is 48. 2 times 24 is also 48. The denominator goes, yes. And what you are remaining with, what remains is 7 times 5, which is 35 times this 990 minus 24. And what is that? That is 900. And this will be 66. Is it? Yes. 80, yes. This is 966 times 35. And you can take out a 2 from here, give this to here. This 35, this will become 70. And this will become 483, right? And now it becomes very easy to multiply. 70 times 483 is very easy to multiply. Let's check that number, 483, yes. So, the final answer, number of ways, final, will be equal to 70 times 483. And what's that product? Let's multiply them together. That's pretty simple. There will be a 0 at the end. 7 times 3 is 21, 1, 2 carries, 7 times 8 is 56, 8, 5 gets carried, 7 times 4, 28, 33. 33810 is my answer for this question over here. That's the complete solution of this using total minus rejected idea. We have also used bag over here, right? Bag idea over here. What's the bag idea? What's the idea of bag? That we put all of those i's together, right? That's what we have done over here. And the idea of bag has also been discussed and used along with this question. That's the complete solution of this. Let me get aside so that you can take a look. And we can move on to the next question after this. Let's discuss this question next. The question says, in how many ways can the letters of the word permutations, okay, be arranged if the words start with P and end with S? Okay, this is the first part. Then there's the second part, vowels are all together. And there's another part, there are always 4 letters between P and S. There are 3 big parts, right? Let's see how do we approach this question over here. Letters of the word P and S and their vowels as well, right? So let's write all the letters of permutations first. Permutation P, E, R, M, U, T, A, T, T, I, O, N, S. You may see that T's are repeating and no other letter is repeating over here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total of 12 letters over here. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters over here as well. Yes, we haven't missed any letters and we have written the consonants and the vowels separately. One of the consonants is repeating, that is T is repeating. It's coming twice. Now let's talk about the first part over here. The first part says, in how many ways can the letters of the word this be arranged if words start with P and end with S? Okay, so starting with P and ending with S implies out of 12 you will be arranging 10 letters at 10 places, and therefore the number of ways will be equal to what? The number of ways will be equal to 10 factorial over Since the two t's are similar, we'll have to divide with the 2 factorial. Yes, this is 10 factorial upon 2 factorial. And what's that value? Can we calculate this value for now, right? Let's calculate this value. 10 factorial is 10, 9, 8, 7 and 6 factorial is 720. We remember that. This is divided by 2, right? What else? This is 4, okay, and this becomes 10 times 9, 9, 4, 7 and 72. So what we can do is let's multiply 7 times 4. 7 times 4 is 28. Okay, and 28 times 9, let's multiply that as well. 28 times 9 will be 280 minus 28, which is 252. This is 2520 and multiplied with 720. This is what we are supposed to do. Right. Let's check that once again. 9 times 7 is 63, 126 and 252. 2520, right? Keep checking the products as well, right? So 252 multiplied with 72, that's what we are supposed to do, and let's do that product over here. 252 times 72, let's multiply them together. This is, we can do it over here only, right? 72 is an easy number, 252 are also easy. So we have 2 zeros at the end. 72 times 2 is 144. There's a 4, you carry forward a 14, okay? Then you add 360 and 14 is 374. 4 and 37 gets carried forward. 144 and 37. 144 and 37. So 44 and 37 will become 81. 181 is what I'll be getting. 1814400 is the final answer that I'll be getting for this part over here. Next, let us talk about the second part over here. What does the second part say? Okay, we can get rid of this. This is not required. The second part says that vowels are all together. Now what are we supposed to do in this one? The vowels have to be placed in a bag actually. P, R, M, T, T, N, S and the vowels. You see all the vowels are there. A, E, I, O, U, all the vowels have it correct. E, U, A, I, O. These have to be kept in a bag first of all, and this bag will be permuted with these other elements. What are these? 1, 2, 3, 4, 5, 6, 7 and 8. 8 in total, okay. So the number of ways will be equal to what? The number of ways will be equal to 8 factorial divided by 2 factorial. Why do we divide by 2 factorial? Because these are exactly same, right? These are alike letters. So we divide by 2 factorial. What else? These vowels which are placed in that bag, obviously they will be, that bag will be kept at one location, but the vowels have to be permuted, right? They occupy 5 places and they can occupy 5 places in 5 factorial ways, right? So the net arrangement will be this. That number of ways will be this. This and this both are required for finding the total number of ways. This is what you do. So what is this? 8 factorial times 2, 8 factorial divided by 2 factorial. 8 times 7 times 6 factorial is 720. Okay. So this is 720 divided by 2 and 5 factorial is 120. This is what we have. Let's say this is 4. This is 28 times 72. Oh, 28 times 72. Did we multiply that? No, we multiplied 9 as well over there. But 28 times 72 times 12 is what we have over here. So let's multiply 84 and 288. What we have over here is 7428. Can we simplify this further somehow? Somehow, yes. 144 and yes, 288. Which will be, what will be multiplied over here? 12 times 4 is 48. So this becomes 480. Okay, and 7 times 720, what is that? This is actually 0. 7 times 2 is 14 and this is 5040, right? This is a good product, right? 5040 multiply 504 multiplied by 48. Now that is what we'll be looking forward to. There are 2 zeros at the end. 2 zeros at the end. 48 times 4, what is that? That is 192, right? 48 times 4 is 192. So you have a 2. And you have a 9 as well, you carry forward a 1. 48 times 5 will be 240. 240 and 1 is 241 is what I get. So 2419200 are the total number of ways in this particular case over here, as you can see. This is the answer for this part over here, the second part. What happens in the third part? Let's talk about the third part after this. The third part says that there are always 4 letters between P and S. Okay, and there are always 4 letters, yes. So let's try to solve the third part over here. 4 letters between P and S, okay. P and S can be interchanged, right? The positions can be interchanged, but since we have total 12 places, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, which places can P and S occupy? Now, please observe which places can P and S occupy. That's the important thing that we want to note over here. So, P and S can occupy, if you see this, if P occupies this, then S will occupy, there are always 4 letters, this place will be occupied by S. But then this is one particular case, right? If, let's suppose, P occupies this one, so S will occupy this one in that case, right or not? Yes. Okay. If P occupies this one, then S will have to occupy this one. And similarly, you will have an alternative case where S occupies this and P occupies this. Okay. S occupies this, P occupies this, S occupies this, P occupies this. Basically, these two in between these two places, S and P can interchange their locations. That is possible. But how many possible locations are there for selecting this first one? So we can select this one, or this one, or this one. If you want to select the last possible combination of P and S, so we'll have to go 1, 2, 3, 4, 5, 6. This is the place, right? If P comes here, 4 places, and this will be the location of S, all right, corresponding to this one. So 1, 2, 3, and so on. You can allot this particular place to P, and correspondingly you will have a place for S as well. So you'll have 1, 2, 3, 4, 5, 6, 7 ways of selecting positions for P and S, right? So 7 ways for selecting positions for P and S, and then P and S can also be interchanged among those positions, right? So you place P and S in these many ways. Now what you have done is, at those 12 places, you have seated P and S such that there are exactly 4 places vacant between them. The 4 places and the remaining 6 places have to be filled. The 4 places and the remaining 6 places have to be filled by the other alphabets, other letters over here, other than these R, M, T, T, N, A, E, I, O, U will fill those places. And the number of ways is something that we have already seen, haven't we? Yes. Number of ways will be this: 10 factorial over 2 factorial. Oh, that's pretty simple. Yes, that looks simple, and that is simple. This is actually equal to 14 times this number and something which we have already calculated in the first part. Let's use this 1814400. This is what we have. Let's multiply them together. This is 00. 14 times 4. Now what is that? 56. You get a 6. You carry forward a 5. 14 times 4 is 56 plus 5 is 61. You have a 1 and you carry forward a 6. Okay, 14 times 1 is 14 plus 6 is 20. You carry forward a 2. What is 14 times 8? 14 times 8 is 112 and you carry forward a 2. So 114 and you have an 11 carry forward. So 14 times 1 is 14 plus 11 is 25. This is 25401600, and yes, that is the answer for this third part. As you can see behind me, this is special and this is important, right? You have to select places for P and S. Out of those 12 places, first select the places for P and S such that there are exactly 4 places between them. Then arrange P and S between those places. The number of ways is 7 times 2. But after that, you also have to arrange the remaining 10 letters at the remaining 10 places. This is the way of doing that. This 2 factorial comes here because the T's are repeating, and we have used that number from there. This is the answer that I'll be getting for this question. Is that all? Yes, that is all in this question. And with this, we come to the conclusion of this exercise based on permutations and combinations, actually permutations only. And in the next video, we'll be talking about another exercise. Till then, see you.